Hello all, welcome to the first video of video lecture series of control system and component. Today in this video we will discuss about the concept of control system, what exactly a control system is. Then we will go for classification of control system, then go for the open loop and closed loop control system. Thereafter we will go the test signals. Thereafter we will summarize the whole video by using a video from a different resource so that you could able to get the concept all in a very clear manner. So let us move to the concept of control system. Control system, as we know, system means interconnection of components or devices or units, okay, to perform a particular task. So control system means the system where the task is controlled by itself, the system itself controls its operation, or it can enable itself to control the operation of any other system. So as it is written over here, a system is an arrangement of different components that act together as a collective unit to perform a certain task. So when they collectively functions, they perform a particular task. Okay, now that task is to be regulated, and that regulation property is there lying with the control system. If a regulating property is there lying with a system, then the system is termed as a control system. That is written over here. Control means regulate or direct. Thus, a control system is the interconnection of various physical elements in a way to regulate itself, to regulate or direct itself or any other system. By definition, it is a system where we can adopt a suitable method or process to regulate the input in terms of its output. That we will discuss how we usually regulates the input and where the means necessity of regulating the input comes, and why the regulation of inputs is carried out in terms of output, why we consider the output while regulating the input. Before going to that, so we should go to the classification of control system. Here it is a tree of control system. Generally, a control system can be of natural type or man-made type. Natural control system are the control system those are existing natural. That means our solar system or a process of photosynthesis or those kind of things. They are the natural control system. But certain systems that already have been means made by human beings for fulfilling their day-to-day life, the requirement of day-to-day life. So those systems are man-made systems. Now, man-made systems are manual and automatic. When a man-made system is called as manually, so we'll go in the subsequent slides. That there we'll able to know of how what are the various components of control system, and in that slides we'll see that there is a process or there is a plant, and the plant or process is being controlled by a controller. Okay, now controller, what happens, it controls the operation of the process or plant. Okay, now the that is been controlled by any operator, that means any human being, in a physical way or in a manual way. That kind of control system is called as manual control system, where an operator, a human being, need to be vigilant all the time throughout the starting process. That means from the starting to the end. So whenever it requires, the person that has to adopt certain means to control, to change or to regulate the process. That happens in manual control system. But in automatic control system, that usually be done automatically by the system itself. No human intervention is means overcome there. Okay, that is the case of automatic control system. Now, when we come to automatic control system, the control systems are of two types: open loop and closed loop control system. So, in open loop control system, there we never see a feedback path from the output to the input itself. But in closed loop control system, there is a feedback path from output to input. That means during regulation of input, we consider the output. So we consider the status of the output in case of closed loop control system. But in case of open loop control system, we never consider the value of output. That means the output totally depends upon the instantaneous value of the input, and that input cannot be changed by your requirement in the meantime of running of a process. Okay. Now, whether that is open loop control system or closed loop control systems can be further divided into two, that is nonlinear control system and a linear control system. Now, what is the linear control system is? Linear control system is that kind of control system where the output of a system that changes linearly with the input. Now, when you can say that the output of a control system that changes linearly with the input, if the control system obeys the principle of superposition and principle of homogeneity. As per the principle of superposition, what it exactly says, that the output of a control system for a simultaneous application of two or more number of inputs become equal to the sum of individual outputs if those multiple inputs can apply to the control system separately. That is the principle of your superposition. Now, another principle is that is called as principle of homogeneity. As per that, every linear control system acts similarly or proportionally to all type of inputs. So, the output of a linear control system always proportional to its input. That is the case of your linear control system. Now, if any control system does not obey the principle of superposition as well as the principle of homogeneity, then that kind of control system is called as nonlinear control system. Okay. Now, for the linear or non-linear, they can be divided into two control systems, that is time variant and time invariant. Now, in time variant control system, what happens? The aspects of a control system, they changes with respect to time. Now, what are the aspects? Aspects means the input or the output or intermediate signals. They are called the aspects. So, output or intermediate signals, they changes with respect to change in time. That happens in the case of time variant control system. But in the control system where the aspects does not necessarily always changes with respect to the time, in that case the control system is called as time invariant control system. Beside this, a control system can be divided into two, that is an analog control system, which is a basic control system, that is a traditional control system, and an advanced control system or digital control system. Those are the advanced control system, and this categorization is done as per the nature of the input. If the input is analog, then the control system can be called as analog control system, and if the input is digital, then the control system can be called as a digital control system. Most of the advanced control system that we presently using nowadays, they are digital control systems or advanced control system. Next, let us discuss about the open loop control system. As I have told you recently, just told you that an open loop control system is the system where you cannot find a feedback path from output side to the input side. So here you are only getting a plant or a process that is controlled by a controller, and the output in this case, that can only be changed when the input changes or actuator signal changes. That means here no feedback path is there, so we cannot change the input as per the output. What is written over here? An open loop control system is a system in which the control action is independent of the desired output signal. That means this controller, what it actually does, it does the controlling, means conversion of input to an actuator signal, the signal which can actually drive the plant. But this controller, it only converts the signal. It never converts or process the signal as per getting a desired output. Okay, that is the case of open loop system. The output signal is not compared with the input signal, which means there is no feedback signal in this system. Okay, so that's why it is called as non-feedback control system. Okay, next is the closed loop control system. As I have told that this is a kind of control system where the control action done by controller depends upon the desired output. Suppose you are operating this system and the plant needs to provide you certain output by any means. the output is not coming as per your requirement, then what you need to do? You always need not to change the input. Okay, because inputs can be generated or can be retrieved, and input value can, in many cases, that remain constant. So for a constant input there will be a constant output, but if that output is not as per your requirement, you need to change the input. Here we are not changing the input, rather we are changing the impact of the input over the plan. How? By getting certain sample of the output and that feeding that sample to the detector stage. Now the detector, what it does, it actually compares the actual input to the feedback input, then it produces an error signal. Okay, that error signal, what exactly with the change in error signal, what happens, the change in actuating signal occurs, so that we can change the process and so that we could able to get our desired output. That can happen in case of your closed loop control system. So that's why it is written over the output signal is compared with the reference input signal and an error signal is produced, then this error signal is fed to the controller to reduce the error to obtain the desired output. Now let us means compare between your open loop control system and closed loop control system. As I said that in case of open loop control system, the control action is independent of system output or desired output, whereas the in case of closed loop control system, the control action is dependent on the desired output. Second, these open loop control system are non-feedback control system, whereas closed loop control systems are feedback control system. Your open loop control systems are easy in designing, easy to design, and your closed loop control system are difficult in designing. Most of open loop control systems are economical in nature, and closed loop control systems are costlier. Open loop systems are inaccurate. What does it mean? Inaccurate. That means if the input is given to the system and there will be no controlling action upon a system, then by any means if the impact of input is changing, then the output will definitely change. In that case, output cannot, you cannot give any guarantee upon the value of output. Okay, fine. Why? Because these open loop control systems are very sensitive to the environment. With the change in environmental factor like temperature, pressure, vibration, all those kind of things, the output be can changes at any point of time. But in case of closed loop control system, you can able to maintain the output at an accurate value, means at the exact value. Okay, so these closed loop control systems are less case sensitive or less sensitive towards environmental changes. Now let us move to the standard test signal. All the analysis and designing of any control system are based upon certain standard signals. In your control system engineering, we usually use four type of standard signal. One is impulse signal, other one is ramp signal, third one is your linear signal, or that means your step signal, and the fourth one is your parabolic signal. Now, what is an impulse signal? Impulse signal is a signal where the signal value is very very high at a particular instant. At a certain instant, the signal has a very high value. But in case of a step signal, the signal has an unit value and that value remain for certain duration of time. Thus, you can see over here, for t greater than equal to 0, the value of the signal is A, and that value remain as it is. So that is a step signal. But in case of ramp signal, the value of the signal that changes with respect to change in time. When the time is changing, the signal is also changing, and the change in amplitude or the value of the signal occurs in proportion with the change in time. That is the case of ramp signal. In case of parabolic signal, the change in amplitude becomes faster, more in comparison to the change in time. So here the signal is parabolic in nature. So these are all that I had to say to you. Let us watch a video from a different source, that is a YouTube video which can make you clear more about the control system. So let us watch.
Hello everyone, welcome to Instrumentation Academy. In this video, we will discuss some basics of control system. First, let's discuss what is a system. A system is an arrangement of different components that act together as a collective unit to perform a particular task. A system consists of three basic elements, namely input, process, and output. The output is the specified function performed by the system. The system itself produces the output as a result of an input being supplied to it. The system changes the input using a series of mechanical or chemical operations to produce an output. This series of actions is called the process. Let's consider that a power source is connected to a bulb. Then the bulb glows. This can be considered as a system. Here, the input to the bulb is current, while the output is light. The lamp filament converts current to light, which is the process. Now consider that we need to control the bulb. That is, it should be on when we require light, which means we need to control the output of the system according to our wish. Controlling the system or control system means to force or direct a system to give a specific output without considering whatever be the input. This is the simple block diagram of a control system. In this we can see two blocks. One is a controller block and the other is the system block. In control system, the input is given to a controller and the controller generates a control signal which is then forwarded to the system block. The system block receives the control signal and processes it properly and finally gives the desired output. For effectively controlling a process, we need to know how the input we are planning to use will affect the output of the process. For this, a mathematical model of relationship between the chosen input and the output of the process is made. The control system can be represented with a set of mathematical equations known as mathematical model. These models are useful for analysis and design of control systems. Analysis of a control system means finding the output when we know the input and the mathematical model. Design of control system means finding the mathematical model when we know the input and the output. Most commonly used mathematical models are differential equation model, transfer function model, and state space model. Control system engineering is the engineering approach taken to understand how the process can be managed by automation devices and to implement such into operation. Control engineering is not limited to any engineering discipline. It is equally applicable to aeronautical, chemical, mechanical, environmental, civil, and electrical engineering. Depending on the configuration, there are mainly two types of control systems: open loop control system and closed loop control system. Open loop control system. A system that does not have any feedback from output is known as open loop control system. This is a block diagram of an open loop control system. In this system, based on the required output, input is given to a controller and the controller generates a control signal. This control signal is given as input to the process. Based on the control signal, appropriate processing is done and the output is generated. Now the system assumes that this generated output is the desired output. As there is no feedback path from output, input is independent of output. So this system is also known as non-feedback system. As this system does not have any feedback from output, the system cannot decide if the required output was attained or not. Open loop control system is also known as manual control system. Now let's see an example of open loop control system. A digital camera is used to take a photograph, which is then transferred to a computer where processing of picture is done. Now a printer is used to take a printout of this picture. As there is no feedback from output, no action can be taken to improve the quality of the picture. Closed loop control system. A system in which the controlling action the output is known as a closed loop control system. This is the block diagram of closed loop control system. This system has an error detector that produces an error signal, which is the difference between the input and the feedback signal. This feedback signal is obtained from the output. Instead of direct input, this error signal from the error detector is applied as input to the controller. Now the controller produces the control signal which controls the process. By this way, the output of the control system is adjusted automatically till we get the desired output. Hence, open loop control systems are also called automatic control systems or feedback control systems. Now let's see an example of closed loop control system. In this example, a control system maintains water level in a storage tank. The system performs this task by continuously sensing the level of water in the tank using a level transmitter. The output from the level transmitter is sent to a level controller. The level controller then compares this feedback signal with a desired tank level to produce the required control action that will position the level control valve as needed to maintain the desired level in the tank. So the level in the tank is maintained at a desired level automatically.
So viewers, by this we have come to the end of this video lecture. I think the fundamental of control system can be understood in a better way by this video. Thank you.